thought you'd like to see just a overwhelming slide that I recently created. I took some things off of this slide just because they had references to some research, and I don't want to run into copyright laws. But I thought I would share this. This is a picture of skeletal muscle hypertrophy, a very incomplete one. But for some of you that are interested in some of the mechanisms of skeletal muscle hypertrophy, this might be useful to you. So Dr. Miller with a download on hypertrophy, skeletal muscle hypertrophy. So I'll walk you through this madness, and you can pick and choose some of the things you might be interested in. And certainly if you have questions, shoot them down in the comments. Please subscribe to my channel. I think you'll be pleasantly entertained with some of the topics I talk about of fitness, strength conditioning. And again, we're talking more mechanisms today. So how do muscles hypertrophy? First of all, there's two types of hypertrophy, and this has been controversial, and I think we've kind of gone full circle back to these ideas of sarcoplasmic hypertrophy. And hypertrophy is more centered around the increase in myofibrils, okay? A myofibrillar hypertrophy, okay? So you're adding in the actual contractile units of the muscle, so a protein, excuse me, so the large or the the bigger myosin and the thin, so a thick filament myosin and a thin filament actin, okay? These two things bind each other, slide filament theory. I won't go over that here right now. But in other words, think about contractile proteins, more strength, where sarcoplasmic is more about supportive structures like mitochondria, okay, like glycogen. These are things that will attract water, and so you have a greater amount of sarcoplasm, goo of the cell, if you will. But you have less contractile proteins. It doesn't mean you don't get any, but it means that it's a little bit less, and that is invoked by how you train. And so if you do different types of training, you get different results. Okay, shocker, right? Specificity of training. Up here, I put a little teeter-totter, muscle protein synthesis and muscle protein breakdown. And so how this thing teeter-totters depends on some factors here that I've drawn in. Essential amino acids, and some people put BCAAs, but essential amino acids, you want all 9 of them, especially leucine, of course. But again, you need all of them. They're called essential for a reason. That will help tilt this little teeter-totter down and increase the amount of muscle protein synthesis. And if you're not familiar with these terms, muscle protein synthesis, think of it as a plus sign, muscle protein breakdown as a negative sign. Muscle protein breakdown is overwhelming, you'd be in a catabolic state. Muscle protein synthesis is higher than muscle protein breakdown, and you're in an anabolic state, at least transitionally, right, depending on the timing of feeding and the exercise and so on. And so if we have more muscle protein synthesis, then you have more muscle accretion. Your muscles should get bigger. So what are some of the factors? Well, more essential amino acids, protein, more muscle protein synthesis, bigger muscles. Okay, that means feeding and resistance training is important. This is why resistance training is a little bit better than cardiovascular training for building muscles, because cardiovascular training can increase muscle protein breakdown more so than muscle protein synthesis, especially if you're not managing your nutrition very well. Carbohydrates, so you eat carbs, you can stimulate insulin. This is post-exercise, and insulin then should block, insulin's an anabolic hormone, and it'll help block muscle protein breakdown. So insulin's not necessarily a promoter of muscle protein synthesis. More than likely, it's more of a preventer of muscle protein breakdown and through carbohydrate ingestion. All right, and there's a balance here with insulin and cortisol that is important, and that's where the muscle protein breakdown mechanism is at least part of it. I don't want to make definites here, because this information, there'll be a study that comes out in 20 minutes that'll probably refute everything I just told you. Of course, we have myostatin. That can be, if you've seen the myostatin, this is the famous first case documented of this little German child that had a deficiency, myostatin deficiency, and so you have these excessively large muscles. We also, like, if you're interested, look at a Belgian blue bowl on the internet. You'll see what happens when there's no myostatin in a bowl. It's pretty entertaining to look at. Myostatin can block muscle protein synthesis through the process of moving satellite cells into their fully proliferated state, and then making new myotubes there and making more active myosin, right? Nuclear domain theory, which has been debated recently as well. And so again, this is all promoting muscle protein synthesis, okay? And this is not a complete slide. Again, somebody watches, wow, you missed it. Fair enough, I probably did. You're right, I agree with you, okay? This is just some kind of a surfacey level look at hypertrophy. And so the type of training then will determine muscle protein synthesis. So if you train with any sort of volume, right, of training, you will see muscle protein synthesis. But the type of muscle protein synthesis will depend on the type of training you do. So if you do more heavy type of training, not to failure, you're going to get more response from the muscles to build actin and myosin than you would the supportive structures, because you haven't really, let me use this term, suffocated. You haven't created a hypoxic environment in the muscle. You haven't created a tremendous amount of metabolites in the muscle to stimulate what the muscle would need next time in order to resist the suffering that it went through. So in other words, if you don't train to failure and you lift heavy things, you're putting a lot of tension in the muscle, but the time is limited. This is also why it can take longer to see gains in skeletal muscle hypertrophy when doing higher intensity lifting, because you can accumulate the volume. Like if you do 10 sets of 3 at an appropriate load, that isn't going to last very long. If you do 3 sets of 10 though, you can come back and do that later in the week for the same muscle group. Okay, it's going to be hard to do that again later in the week, and so the total accumulation, the accumulation of total training volume over time, then it's going to be much higher when you use that moderate to high repetition range sets. And so, not to failure training and these higher loads, higher intensities with lower volume per set. I put a 6RM here. Anything underneath that, it's going to generate more of the contractile proteins. That's the type of training that you did. High tension, low time. Okay, SP here is the size principle. So both of these types of training, the high repetition or the low repetition type of training, is going to increase, are going to move you through Henneman's size principle of motor recruitment. And so going from the smaller Prius car up to the dragsters, the type 2s, and grab those type 2 fibers and train them, you can do it 2 different ways. You can go not to failure in more the maximal way, or you can do it through the repetition method and using more fatigue, but closer to failure in order to recruit those fibers. I'm not saying go to failure. I'm just saying that you're going to be closer to failure. I'll mention mTOR here, mammalian target of rapamycin. So it's just an important biochemical marker. Just for the sake of this talk, I don't want to get into it much more than this, but it is an important marker. I have it up here as well. When you look at mechanotransduction, this is mTOR is part of that process again in order to move to skeletal muscle hypertrophy. It's one of these highly studied signaling, part of a signaling cascade in order to move the muscle to produce more skeletal muscle, probably through the myonuclear domain theory. Okay, or nuclear domain theory. Now, mTOR is inhibited by a condition when the muscle has been depleted, and so when there's a lot of fatigue generated, there's a lot of energy used, right? And so if you're familiar with some of these terms, ATP is think of this as a full battery. AMP is a battery that's been used, is expended, and when the body recognizes there's this little switch, as we call it in the muscle, this AMPK switch. Essentially, when the batteries have been used, there's more AMP and the batteries are full as ATP. When the batteries have been used, AMP is now signaling through AMPK this switch saying we're in a low energy state. In other words, we've blown through the energy. And that can be helpful in moving towards different energy systems. But to the muscle then, in terms of how it adapts, it's more of a signal that, hey, build this supportive tissue, more sarcoplasm, we need more mitochondria, we need energy. Okay, we became energy deficient. Over here, when you go to these heavier loads, not to failure, you're not as energy deficient. It's more of tearing up muscles through tension and neurological processes. Over here, that's less so. Okay, you get more of again, an energy challenge, and so you get adaptation that follows that. And I put running in here, this idea of concurrent training. It's going to interfere through muscle protein breakdown, especially if you don't manage your nutrition. It can interfere, well, it does to some degree, no matter what, interfere with muscle protein breakdown. It can be blunted by the type of training, how intense, how long this training is. There's a lot of factors here. Your nutrition, so on and so forth, determines how much muscle protein breakdown there's going to be. But that produces fatigue as well, which is going to negatively affect volume, which in turn can negatively affect the total volume that can be trained with in order to produce skeletal muscle hypertrophy. So you kind of have this nasty cycle that can happen with too much cardio, is where you negatively affect the volume of training, and in so doing, then the training drops, and so in so doing, you either don't get the skeletal muscle hypertrophy in the sarcoplasmic side because you can't do the volume, or you don't get it more increasing the myofibril side, and so now you reduce the amount of force that the muscle can produce. All right. I'm not saying don't run or do cardio when you do training. I'm just saying be mindful of its impact on creating skeletal muscle hypertrophy. Okay. That's what I wanted to highlight here. I won't talk about mechanotransduction. I just wanted to talk more about this basic understanding of skeletal muscle hypertrophy, some of these inputs and outputs that result from what we do in training and what we do with nutrition. So I hope you found this slide helpful. Again, it's just a summary. I'm sure somebody could pick it apart, and maybe somebody will and say this is me, but hopefully the general understanding of it will be helpful. I'm going to end the show here. I guess I kept clicking on that.